Okay, so like this is the third part, and we're gonna move with some difficult stuff, but that's fine. So, question: what is the x squared y cubed term of the expansion 2x plus 3y to the n? So we have a couple of things to do here. First of all, what's the first thing you might ask yourself? Yeah, what's the n? Right? What's the n? Well, what do you think? Correct. We know 2 plus 3 is equal to the n. So n equals 2 plus 3 is 5. That's fine. Now, we are interested in the x squared y cubed term, so we can write it out. We know it's 5 to something. We know it's 2 to the x something. We know it's 3y something. Right here, we've pulled all the coefficients out, so we just get x squared y cubed, but there's a 2 here and a 3 here. So we have a lot of numbers. It's a calculator problem. It's just tedious. It's not difficult. So you're like, okay, well, this is 2, this is 3. Because Pascal's triangle is symmetric, we're going to put the 3 down here. And then we're going to pull out all the garbage, like pull the numbers out. So we have equals 5 choose 3. Pull out the 2 squared. Pull out the 3 to the third. And then we have the x squared y cubed. And then you go to your calculator, and what do you got? What is this whole thing? 10,800. Definitely a calculator problem. I really don't want to see on a test, if you have a calculator, you figuring this out. You don't have the time for it. Now, yeah. And, yeah. Okay, and then next one. What is the x to the third coefficient of x minus 3 to the fourth? So you're like, this is easy, Mr. Adler. Why do we need a whole lesson on this? It's the fourth, so it's 4 choose something. We know it's x to the something, negative 3 to the something. Well, I asked for the x to the third time, so x gets the 3. I know the sum of the x1 has to equal 4, so this is 1. Stick the 4 down here, and it's easy. It's negative 12x to the third. So these are the type of problems that you're going to see in SL, but these are like the 1, 2, 3, 4, 5 level. But what IB does is they've been like putting in more advanced problems. So this is 6, 7 level questions. Okay. So the idea is I need you to have this stuff mastered before you ask me about these. So let's go on. Here's something. Ready? What is the constant? What is the constant in the expansion of 2x plus 1 over x to the 8th power? Okay. What's going on there? It's on the SL exam. Sorry, but we have to deal with it. But I'm saying again, it's a 6, 7 level. If you want the 6, 7, you need to know how to do this. If not, you're a 4 or 5 student, that's okay. Another word for constant might be independent. And the idea is that there's no x term, which is fine. That's fine. We know x is going to be raised to the 0 power. It's the last term in the expansion, but sometimes these don't look like it. Some of these have like negative powers. That's fine. So the question is, let's go back. How do I do this? Because you don't want to expand that out to the 8th power, and you don't want to write Pascal's triangle. And so you're like, no. First of all, what is any term? What is any term? So you say, okay, well, it's a to something, right? To the x to the something. and 1 over x to the something. You're starting off, right? Right? So let's go on. Well, what is this ratio? You go, I don't know. Well, I don't know math is a variable, so let's pick the letter B. So this is B. Well, what is 1 to the x raised? Well, once again, I don't know that, but I do know that the sum of the exponents has to equal 8. So if the sum is 8 and this part is B, what's left over? 8 minus B. Okay. And then we know that 8 minus B comes down here. Okay, no big deal. So let's pull the garbage out and let's pull the numbers out and deal with the exponents, or the exponents of the variables, okay? And once again, this is a 6th level. You understand exponents, so you're gonna have to, so ready? So let's pull it out. So with 8, choose 8 minus B, 2 to the B, that's the numbers. Now we're dealing with the exponents. I have x to the B, ready? Are you ready for this? X to the B minus 8. Remember, 1 over x is x to the negative 1. Negative 1 times 8 minus b is b minus 8. I'll write that out once and only once. 1 over x is equal to x to the negative 1. That means 1 over x to the 8 minus b is equal to x to the negative 1 times 8 minus b, which is equal to x to the b minus 8. Nice. So we have this. We have our 8 choose b. We have our 2 to the b, and we have x to the 2b minus 8. Well, I'm looking for the constant term. So what must x be raised to? Good, the 0. So we're going to let 2x minus 8 equals 0. B equals 4, and when b equals 4, we're going to get our term where there's no x. Plug the b back in here. So we have 8 times, choose 8 minus 4, 2 to the 4th power. This ends up being x to the 0. Use your calculator. What do we get? 8 choose 4. We have, I'll do it over here. 8 choose 4 times 2 to the 4th is equal to 1,120. Let's try another one together. Once again, this is a 6-7 problem. Ready? Let's see. What is the x to the 5th term of 2x minus 1 over x to the 7th power? Ugh. This is why it's a 6-7 problem. It's going to show up, it's question like 7 or 8, and it'll take you up to the 6th and 7th level. Let's see what's going on here. Okay, no big deal. So I have 7 choose something, 2 to the x, negative 1 over x to the something. Let's use, what do you think? Let's use the letter C. This is C. This is 7 minus C. Okay. And we know this is 7 minus C. Let's pull all the junk out. So we have 7 choose C minus C. We have 2 to the C. We have negative 1 to the 7 minus C. We have x to the C, and, ready, x to the C minus 7. There's that little trick, because good kids know that. So what's going on here? So we have x to the 2c minus 7. I need that to be equal to 5. That means c equals 6. So we're gonna have so it's gonna look like this. So it's 7 choose 7 minus 6. I could do it right here, actually. I have 2 to the 6th, -1 raised to the 7 minus 6. I have, and we already know what this is. We know this is going to get me x to the 5th, right? Because it's, what do we have here? Yeah, this is 12. Yeah, no, that's fine. Sorry about that. 6. Yeah, 6 minus 1 is 5. Sorry about that. And so we know we have x to the 5th. So let's see. This is 7, choose 1. This is 7. 2 to the 6th is 64. -1 to the 1st is -1. Final answer is -448 x to the 5th. Okay, let's try another advanced one that showed up on another IB exam. I was surprised these showed up in the SL exam, but you know what? They showed up, so we have to deal with it. Okay, let's see. So, what is the x to the 4th term of, ready? This is kind of interesting. X squared times 2x plus 5 to the 5th. I'm sorry, this is a little sloppy. Yeah, x to the 5th to the 5th. What is up with that? Well, it's no big deal. But first of all, let's expand this out. Let's see what happens when we expand this out. We know we have 5 choose something. We have 2x to the something and 5 to the something. Okay, so we need the x to the 4th term. And if there was no x squared here, you'd say, this is no big deal because I know this is to the 4th, that's to the 1st, and this would be 1. But the problem is, I'm multiplying this by x squared. So you know what? I'm going to make this a 2. Once again, knowing that the whole expansion, that this is an x squared, and I'm going to be multiplying by x squared to get to my x 4th, I'm going to make this 2. That means my 5 is going to become a 3, and my r, the term here, that's 5 choose 3. So it's not, you gotta put on your thinking cap a little bit, and that's the idea. So what is 5 choose 3? Let's see. This is 10 times 4 times 125 is equal to 500. No, that's not right. 10, 4, that's 500. 40 times, I think it's 5,000. All right, 5,000 x to the 4th. Once again, please remember, we're just getting x squared, and then we're multiplying it by another x squared to get to our x 4th. Let's try another one. Here's the last one. This is really advanced, but you know what? It shows up in the IB. So, let's take a look at this last problem. What is the x to the 5th term of, you know what, let's make it to the 6th. X to the 6th term of x plus 2 to the 3rd times 2x minus 1 to the 4th. It showed up on an IB exam. I don't make this stuff up. Once again, if you want that 6 or the 7, IB is saying for SL students, you have to know how to do this. Fine. Well, if you think about it, it's not so bad because, yeah, if you think about it, it's not so bad. I mean, you could, a little old school, let me get my chair over here. If you wanted to deal with this problem, you could expand out the x squared. So you know it's like you have like 2x, it's like x to the 4th, 2x to the 3rd, 2x to the second, 2x to the first, and then like the constant term. Like you know how this expands out, so it's 1, 1, 1, 1, 1, and you put past the coefficients on here, and then along here, you do x plus 2 to the third. You're like, okay, this is the x to the third, this is x squared, this is x, and this is x to the 0. And then what you do is you say, okay, I need the x to the sixth term. You say, oh, you know what? X to the third times x to the third, these two terms multiplied together will give me the 6. And x to the fourth times x squared, this will get me the 6. So I have to figure this out and multiply by that, and then this and multiply by that. You could do that and run the numbers if you wanted to do old school. That's fine. I'll say it again. Expand these out quickly because you know the patterns. These aren't difficult to expand. And then look for all the combinations that will get you x to the sixth power. X squared times x to the fourth will get you x to the sixth. X to the third times x to the third will get you x to the sixth. Let's take a more sophisticated approach. If we're a 6-7 student, let's take a sophisticated approach. So first of all, what are these expansions? In general, what are these two expansions? You say, fine. The first one is 3 to something. X to the something, right? 2 to the something. Okay. And we're multiplying it by another expansion. And what's that expansion? You say, okay, that's 4 to something. That is 2x to the something. -1 to the something. Okay. We're not sure. Well, let's see what's going on here. So what was the last letter we used? I think it was like C. Let's use D and E, right? So right here, we have D. This is 3 minus D. This is 3 minus D. What's going on over there? Well, this is E. This is 4 minus E, and therefore this is 4 minus E. Let's pull all the numbers out because I want to deal with it. I need x to the 6. How are we doing for time? Good. I need x to the 6, so we can manipulate it. So let's pull all the numbers out. So we have 3, choose 3 minus D. We have 2 to the 3 minus D. We have 4, choose 4 minus E. And we have 2 to the E, and we have -1 to the 4 minus E. What's left over is x to the D, x to the E, right? So let's think about it. We just pulled everything out. Well, what do we need D plus E to equal? We need D plus E to equal 6. Now, this is known as a Diophantine equation, which is simply these type of linear-looking problems with 2 variables with integral solutions. Well, what are the possibilities? Are there that many? Well, we already know there's only 2, but if you think about it, it's really not that bad. How many possibilities? How do we get to 6? Well, if D is 0, E is 6, but my exponents only go up to 3 and 4. So I can't use 0. I can't use 0, 6. That's out. 1, 5, that's out. 2, 4, that's good. How about a 3, 3? That's good. How about 4? Well, no, D's to the third power. I can't go any higher. I'm done. So once again, the only two possibilities are that D is 2. The only possibility is that D is 2, and E is 4, or that D is 3 and E is 3. So let's just plug it in. Let's see. We have 3 choose 3 minus 2. 2 to the 3 minus 2, 4 choose 4 minus 4, 2 to the 4th, -1 to the 0, And then what's going on down here? We have, let's see, is 3. So we have 3 choose 3 minus 3, 2 to the 3 minus 3. Let's see, what do we have here? 4 choose 4 minus 3, 2 to the 3, negative 1 to the 4 minus 3. This is easy. Well, what's 3 choose 1 is 3 times 2 times 1 times 16. That is, let's see, 6 times 16 is 96. What's going on here? Let's see, 3 choose 0, that's 1, 1, 4, 8, negative 1, minus 32. Final answer to this long problem, what is it? 64.